All right, guys, lesson 3.6, projectile problems 2, which is basically shooting them at an angle. A lot of stuff we've kind of covered. It's just really getting into specific problem here. So basically, we're looking at something like this. Launched at 60 degrees, initial speed 35. So like normal, we'll always draw out our components for our velocity, our initial velocity. I did 60 degrees. That made it kind of easy on me because I know this is going to come out to be half of the hypotenuse. You could do a cosine there, and then I know that if I do 17.5 times the square root of 3, I actually get this like here, 30.3. Okay, you could also use a sign there. Okay, this is my VXO. This is my VYO, right? Okay, let's look at our equations we got. That was our Vy equation. Vx is constant. And then we had our D equations. dyo plus vyot plus a half at squared. And then what was dx? Just equaled vxo times t, right? Because that was just constant. Okay, so these are the questions you're going to run into. What's the time to get to the max height? What is that maximum height it reaches here? And then also the time to come back down to the ground here. And then how far did it actually go horizontally? Those are the main questions. There might be some other ones you run into, but those are the main questions. Okay, so let's look at this scenario here. Time to the max height. The key there is that at my max height, my Vy is actually 0. Okay, so at this point, I know my y velocity has gotten down to 0. Vyo is the 30.3. Negative 9.8 is my acceleration, t squared. Okay, so got to solve that out for t. So 30.3 divided by 9.8, and then square root that. I'm getting 1.76 seconds to get to the height, to get to the max point. Okay, what is that max height? Now we're talking the displacement, the dy. Dyo is 0. The Vyo is the 30.3. The time is the 1.76 seconds. See if I can squeeze it all down here. 1/2 negative 9.8 meter per second squared times 1.76 seconds squared. Okay, I'll just plug that all into my calculator here. Okay, so 30.3 plus, or I'm sorry, times 1.76, and then it's going to be a minus here, 4.9 times 1.76 squared. Okay, I'm getting 38.1 meters. Okay. When I work out that whole mess. Okay, that's the max height reached, 38.1. Okay, and then let's move on to this. When it hits the ground here, what's going on? We want to know the time to get to the ground. Okay, so to the ground, your time will just equal 2 times the time it took to get to the top. So 2 times the 1.76 seconds. So what is that, 3.52, I think? 52 seconds. Okay, that's easy. Just be double. This answer is just double that one. And then how far did it go? That's actually pretty easy too. That's just your dx. Remember, that's vxo times t. So my VXO is a 17.5 meters per second there from over here. And then my time, make sure you use the 3.52 seconds because I want to know how long we're talking about when it hit the ground here, you know, how far did it go horizontally. Okay, so I'm getting 61.6 meters. Okay, that's the answer for this question. Okay, so kind of a lot of stuff going on there, but it's hopefully you're building your understanding so that's all kind of is making sense here. Okay.